Okay, cool. So our next speaker, well, first of all, when you see him come out here, you'll know that he works for he's the finance part of the U.S. government. You'll see. But he was the national U.S. Olympic champion throughout the 2000s. And he competed for Team USA. He trained at the Olympic facility in Lake Placid. And I just really have to have a question. As the karate champion of the USA, did you win the All Valley tournament? All right? The All Valley under 18. Everyone, please welcome Richard.
So today I'm going to tell you about dozens of file formats, and then I'll demonstrate a tool that you can use on any Shiny server to help select the optimal format for your project. Oh, there's of course this disclaimer. These are only my views and they do not reflect the commission or the commissioners or anybody else at the SEC. So who really cares about the file format? Well, you should. If you're using a file format like Excel to do your work, you could be experiencing thousands of times slower read and write speeds than if you're using an optimal format. If you're using RDS, the standard R format, it's better, but on a powerful system, it could still be like 1/600th of the speed of a faster format, and thousands of times slower in terms of writing because it writes so very slowly. And then most of all, your users are really going to notice a difference. It can be the difference between your application being completely unusable and blazing fast. So why don't I just tell you which one is the best? Well, if there was a clear answer to this question, then I'd have no need for this presentation. But it turns out the best format hinges on a bunch of factors: your system, your data, and to a lesser extent, your other goals: interoperability, whether other people are going to be accessing the data and updating it independent of your system. In general, we have to think about how we would measure this, how we can say one is the best or not. So I'll measure reading speed, writing speed, file size, accuracy. So reading, writing, and file size is very clear: faster, smaller, better. But accuracy, by that, it just means, do you get back what you put in? So if you save the file and you reopen it, are you going to get the same thing? So it turns out that most of the fastest formats are going to discard a lot of the R attributes along the way. So there may be a little trade-off there. Oh, system characteristics. Did I go too far? Oh, no, I still want to talk about other considerations. So in a lot of cases, you have mandated data formats like XPT, which is the FDA's required format if you're going to submit anything to them. But others still want to use Stata, and might be required that you use SAS or that you use SPSS, depending on who your colleagues that you're working with are. Well, even in that case, there are multiple formats that you could choose from. So we can benchmark those as well. So I have all these in there, and then you can choose which ones to benchmark and compare and decide whether or not you want to go through the trouble of using more than one format. And of course, we'll talk more about multiple data users at the same time. And your data matters as well as your system characteristics. So your CPU cores can make a big difference. So a lot of the faster formats allow multi-threading, which allows you to decompress the data using multiples of the same infrastructure that you'd be using in a single threaded environment. So that can really have an astonishing effect. But again, it's really surprising how much of a difference there are between the formats. RAM, of course, is going to set an upper limit for how much data you can have in memory. And if it's faster RAM, how fast it can go in and out. And then finally, your storage disk throughput can make a huge difference. Like if you have a RAID 0 SSD gaming laptop, you may be able to do some incredible things with your data. But what really, and it's going to be, light years different from if you're trying to run your data off of a thumb drive. But just within like the Amazon infrastructure, if I use an EFS solution versus like the native data that comes on my instance, it's extraordinary. It's like, multiple orders of magnitude difference in read and write speeds. And I wasn't aware of how much of a difference it made. And we have some network drives that are really fast, and I never noticed that there's any kind of lag when I use these network drives and network in my agency. But if I use my local hard drive, it was so much faster once you get the benchmarks in play. And that can make a difference depending on how and where you're storing your data. So obviously data size makes a difference, and a counterintuitive one, as we'll see in the benchmark. Some for smaller size files, you would be surprised that certain formats excel versus others. But does your data contain exotic data, geometric data, SF formats, and different file types like that? If it has long strings or special characters or special R attributes, we'll look at the nuances of all of these as well. So I think it's simple. It's best to kind of break out all the different file formats into these three categories. We have flat files, CSV, XLS, JSON. Now, well, compressed files, databases on disk. Now, if we talk about the flat files, we'll see that all of these you can open up in Notepad and navigate them and pull out some information. Even though there may be XML tags or they might be nested lists, you can understand them to some extent. And you'll notice X's everywhere, but none of the other tables are any better. There's X's everywhere. There's not a single format that has check marks across the board because there's always some sort of a trade-off here. So obviously the first one is this multi-threading, which, kind of suggests anywhere you see a check, these are certainly going to be the fastest on these, the fastest of these formats, and they speed up your compression and decompression of the data. Almost all the flat file formats have problems with long character strings, as you can see. For example, Excel famously only allows about 36,000 characters in a cell. And yeah, unfortunately, all of these, at least given the I don't necessarily have the package names, but in a lot of cases, it is the package name in parentheses. But almost all of these formats fail when it comes to really long string files, and we'll look at that. Complex vectors just refers to R's ability to store real and imaginary parts in a single vector, and none of them are capable of doing that. R attributes, well, R makes it so easy to add additional attributes. And I don't know if anybody else does this, but when you have a new data set, it can be awesome to, like, I have this loan data that I'm going to show you in a little bit with 110 variables, and it's hard to know what each one is, but you can add really long paragraph attributes at the top of your table that will get discarded by a lot of formats, but you might want to keep them. These results in smaller file sizes than all the flat file formats, these compressed files. And it should be noted that many of them, the compression can be turned up, and then it's going to slow down the read and write, or it can be turned way down, and then it will be a lot faster and slower. But again, I'm using defaults all the way through. And so it might be that one format is superior in a lot of ways, but we wouldn't know it because we're only comparing the default settings. And then finally, I want to talk about some database on disk files. Now, of course, there are several other options. DuckDB is a terrific one, and so is our SQLite. And we'll see that each excel in different ways. The real advantage, I think, is that of using these is that the data can be easily accessed and updated by a wide variety of computer systems. So other computer systems or other users, or there are a lot of situations in which you don't want to be, or you don't necessarily want to be the only one who can access the data. You want others to be able to attach that, to work with that file. And in fact, I found DuckDB to be a little bit better in that case, in case there's like conflicts of them both writing at this, before it gets saved. All right, so let me find out here. We're ready for a demonstration. So using this, well, now it's up to 25. My notes say 22 kilobyte file, but I've added a little here and there. But using this single .r Shiny file, you can benchmark all these file formats against one another using any data on any Shiny compatible system to find the optimal format for you. So we'll see how on different systems of different power with the same data set, we get different results. If we use different results on the same system, we get different results. So it could be, well, I think it's interesting. We'll see. So when you first open the tool, the first thing you see is the ability to open a data set. So I'm going to open this Fannie Mae, Freddie Mac. This is loan performance data. It's free online. After you've uploaded it, you can click Uploaded Data. And it had a bunch of fancy characters that were creating an issue, so I deleted the headers here. But we've got 110 variables on loan characteristics. And once the data is uploaded, yeah, we can see it all here. For now, we're going to focus on generating synthetic data, so I'll put this away. And let's look at the synthetic data. We could change, now at this point, we have 10 integer columns. If I change it to 1, now we just have 1 integer column. Let's go back to 10. Let's change, so if we go over here to our string columns, we can see there, in fact, I'll just move these over. Do 1 decimal column, and then we get to the strings. Now, if we wanted to make the strings 1,000 characters long, then shouldn't take too long. There you go. Well, it's surprising. Oh, that's the number of characters. I meant to put the 0 over here. So the string length, let's make it 1,000 characters. There we are. So you can quickly create any sort of synthetic data to compare against. So I'll just go back to my defaults here. And the next thing you can do is choose among your formats. Now, for now, I'll keep them all checked. The next we can choose is the number of iterations. So you should always run at least 3, I'd say 5, 10, at least 10 would be great. But once you get to about 5, you'll be pretty clear. I find that there's variation, especially if you have other messages coming in, or if you're using many gigabytes of data and you're writing and reading thousands of lines, or millions of lines, then you'll see differences in the output. So it's useful to have more than one. So finally, to benchmark the files, we just click this big green button and we wait for a moment. In the meantime, it should be up and running by now. Let's see, is it? Oh, here they are. So the first thing you'll notice, there's such a wide gulf between the slower and the faster formats that you can't even judge the top 60% of them among each other. So for this reason, I recommend clicking the checkbox at the top of the page that I ignored earlier, the hide slow format. So let's get rid of this hide slow formats. They're no longer in the list here. And when I rerun it, we'll have a better view of what's happening here. So here we have QS winning in read time, and we can sort them by write time. R SQLite is first here in today's demonstration. But again, the files are so small. Maybe if we add a couple more zeros here, it'll be a little bit more meaningful. Oh, maybe I should have, there. Well, it already worked, so that's fine. So this is with a 10,000 rows, in spite of the fact that I changed that number. And now QS has fallen down a little bit, and we'll see more results in just a second. I wanted to point out that it will get your system information. So this system has 64 gigs of RAM, 20 cores, and depending on, again, how many cores you have wildly different results among the different formats. Let's go back. I want to highlight something about this QS format. So you'll notice there's 3 different QS formats here. There's QS, QS2, and QData. So in the month that since I agreed to do the presentation and been working on it, the developer has come up with 2 new formats because R changed its internal API standards. And now, in order to make it future-proof, they have the QS2, which will be backward compatible, and then QData will be compatible with Python. So for all the Python users out there, this will be, we'll see if it's a good competitor to Parquet. All right. When you select the raw, so you can see all of these, the graphics here. We can see them in this process table. So it's basically the same table, just in table format. And what I've done, these are not the median of the results. These are not the mean of the results. This is the median of the results. By using the median, then we have the ability, to evade all of the, so yeah, here we have almost, wow, this is a huge difference. This is almost triple the difference in time, right, between the fastest and the slowest. So the median is going to give you a pretty consistent result. And these are in picoseconds, but of course the process results are normalized to regular seconds. Okay, so I'm going to try to move forward to the actual results, which I think are interesting. So here we see this, we see QS leading the pack. Now, if we use slightly larger files, the feather, I'm sorry, I should say the arrow formats, Feather, Parquet, and CSV, really catapult to the front. And these files are between 150 and 400 megabytes, and I think this was done with 5 iterations. They just open in seconds. And the one downside to all the arrow formats is they're much larger. So QS is always the smallest across all systems and all file types, but they don't keep up in terms of speed when it gets to larger size files. Now looking at super large files, this has 10 million rows. These files are between 1.5 and 4 gigabytes. It's so surprising. I thought that something must have been wrong, because when I look at a format like QS, which had always been very, very fast for my own work, it takes 40 seconds to open this file, but it takes about 0.6 seconds to open the Parquet and less than 0.2 seconds to open the Feather version of this file. So as a sanity check, and this is the same as, well, we can just, we're running low on time here, so I'll jump ahead a little. I pulled this up. It's 2.2 gigabytes in Parquet. Of course, it might be smaller in the other formats, but it really opens up in 0.6 seconds, and it's ready to go in memory and perform at a rate that's I was really grateful to see this, actually, because there are a lot of cases where I want to use data like this, and instead I'll serialize it in some way or figure out some way to not open a huge file or not have it all in one place, or I'll have to spin up a database and leave it in there. But if I can do this and have it in memory that fast, that's pretty awesome. Okay, so now let's look what happens when we use long strings. So these files involve rulemakings that are between 100 and 1,000 pages, and these are all in a single cell. And then I have a bunch of NLP on other columns, like number of words and sentiment and other kinds of what does AI think of this document and so forth. So these files, they're not that big. They might only have a couple thousand rows, but because there's so much data in a single cell, somehow they're prone to crashes. But with certain formats, they really work great. And here, R SQLite just cuts through them fast. It's really impressive, the results we're getting. And here we can see let me see. Notice how we have CSV FWrite doing so terribly here with this long strings data in terms of reading and writing. Now, when we go to the loan data, which we had loaded earlier, we'll see FWrite is now in the middle of the pack, and it's number 1 in terms of speed. So if I go back, I can, the writing speed is, 1/10 of a second to save all of the loan data. So it's ponderous and it's consistent. If I keep, I can run these with 500 iterations, I'm still going to get this type of breakup. So it really depends on your data and your system. And they don't move in the rankings when you change the file format, or if you change the data, or if you change the number of iterations. So the last thing I wanted to talk about was geometric data. And I just want to drive home a simple point. Now, I know that if you change some options and you load some packages, then DuckDB might be good with SF objects. In my experience, I couldn't get it to save any SF objects. It just kept telling me it wasn't supported. So I'm going to tell you that it doesn't work. But I downloaded this, freely available geometry data from the Census Tiger program, and it's like 3 megabytes. It's as detailed as you can get at the state level for the state boundaries. And then I just randomly shaded it. And you'll notice we only have 4 formats here. The only ones that could keep the R attributes or these exotic formats were RDS and the QData formats. And again, QS wins in all of the categories here. It's the smallest and fastest. So in summary, well, actually, before I sum up, I want to provide again the disclaimer that I use only the default settings for all these formats. So it might be the result of bad compression or some other factor. Maybe they limit the number of cores in in FST or something. But at the defaults, this is what I'm getting. And you can, you're invited to tweak it out to do it the same. But I think nevertheless, it still suggests a few things. QS seems to be a worthy replacement for RDS. I could not detect any advantage of the R data format for the QS family. I guess the question there is which one to use. I'd probably use the newest one called QData, which is compatible with Python. And despite some restrictions on which R objects could be saved, The arrow formats were super fast and the fastest. And they, while they lose certain R attributes and they're not good for saving lists. Oh, and somebody said before you can't output multiple objects in R, but you can output a list. So you can output as much as you want. So anyway, I disagree. Among the database files, I seem to have better luck with DuckDB, especially with smaller files. But then vice versa, when the files got larger, then R SQLite did a really good job. But overall, anytime you use those, it's going to take up a lot of space on disk, and you're using it. I think you should use that probably if you have other users or if you have another reason to keep your data shared. So don't take my word for it, though. Hopefully you can deploy this yourself and see what's best on your system. And feel free to reach out with any questions or feedback. And thank you for your attention.